All right, this is part two. Part one was minerals. This is going to be just ES5 rocks. And the first thing we're going to do is draw a rock cycle. There's three types of rocks, as we've talked about at length. There's igneous, there's sedimentary, and there's metamorphic. So igneous rocks, in order to become igneous rocks, first have to be molten rock. That is lava if it's on the surface, magma if it's underground, and molten rock, in order to become an igneous rock, has to cool and crystallize. I think there's two L's in there, but that's okay. Cool down and crystallize to become an igneous rock. Has to solidify. Likewise, igneous rock can always melt again and turn back into molten rock. As a matter of fact, any kind of rock, whether it be igneous, metamorphic, or sedimentary, if it melts, it becomes molten rock, and then the only thing it can do is cool and crystallize and become igneous. So like igneous rock has an intermediate stage here as molten rock, sedimentary rock has to first be sediment. Now, sediment can be sand, dirt, mud, silt, clay, broken down rock materials. And the way rock materials get broken down is through weathering and erosion. So if an igneous rock is exposed to the elements, wind and water, it's subjected to weathering and erosion, and it becomes sediment. Likewise, if a metamorphic rock goes through weathering and erosion, it also becomes sediment. And even a sedimentary rock, and I'm just going to put W and E for space here, weathering and erosion, sedimentary rock also becomes sediment. And once a rock is sediment, it has to become sedimentary. Sediment becomes sedimentary through compaction and cementation. So sediment goes through compaction and cementation to become sedimentary. That's kind of smushing down. And there's only one kind of rock left now. Sedimentary rock, to become metamorphic, is exposed to heat and pressure, or sometimes chemical action, but for this activity I'm just going to write heat and pressure. Igneous rock can also become metamorphic. Metamorphic means change, so heat and pressure can change a rock into a different form. And metamorphic rock also, if it's exposed to more heat and pressure, can change even more. So I like to do that little loop there. So we've got a complete rock cycle here. Another thing to keep in mind is that every type of rock, like igneous rock, can be broken down into subcategories. So igneous rocks can be extrusive or intrusive. So to become igneous is a molten rock when it cools down. If it's on the surface of the earth, it's extrusive. If it's underground, it's intrusive. And there's some other differences between these two. Extrusive rocks cool down faster, and intrusive rocks cool down slowly because it's a little warmer down there as far as the rock's concerned, and that leads to smaller crystals in an extrusive rock and larger crystals in an intrusive rock. Sometimes too, an extrusive rock will have air bubbles, and an intrusive rock will never have air bubbles. So if you see a rock with a bunch of air bubbles in it, that's an extrusive igneous rock, like basalt. Similarly, metamorphic rocks also have two categories. They've got foliated or non-foliated. Now, foliated just means stripes, also called banding. So your rock will literally have stripes, and that's because the minerals inside of the rock, remember rocks are made of minerals, the minerals separate out by density. So each stripe will be a different mineral. Non-foliated just means no stripes. Another important thing to keep in mind when you're thinking about metamorphic rocks is parent rock. So the parent rock is whatever it was before, if it's an igneous rock or a sedimentary rock. So every metamorphic rock has a corresponding parent rock. So when granite is exposed to heat and pressure, it becomes gneiss. And when limestone is exposed to heat and pressure, it becomes marble. And when sandstone is exposed to heat and pressure, it becomes quartzite. So every metamorphic rock has a parent rock that it was beforehand. Last category is sedimentary. The sedimentary's actually got three different categories. There's clastic, organic, and chemical. Clastic is just made up of bits of other rocks or sediments. Organic means formed from once living organisms like coal, and chemical is formed through evaporation, like the crystals we made in class. So clastic rocks, that's going to be like sandstone, mudstone. A lot of times with sedimentary rock, there's a clue, like a sediment is in their name. Sand is a sediment, mud is a sediment. If it's called sandstone, it's a sedimentary rock. Limestone, oddly enough, can be either chemical or organic. So sedimentary rocks form from weathering and erosion, and that comes from wind and water. So down from the mountains into the lake. They get carried by water, usually in a river, and they form when they get deposited in the bottom of the lake. So here's the surface of the lake, and then the bottom of the lake has these layers of sedimentary rock. And the oldest rocks would be on the bottom, the newest rocks would be on the top. And this is where the compaction comes in. This is the very top layer, that would be like newer sediments, but underneath of it you'd have more and more weight on top of the layer. So the water and the layers on top are compacting these layers, turning them into sedimentary rock. When they're carried downstream, you have different types of sediments. Upstream, you're going to have angular grains, and downstream, you're going to have more rounded grains. Upstream, you're also going to have more different sizes. There's more stream energy upstream, and it's carrying lots of different sizes of sediments. Downstream, closer to the lake, most of them are going to be close to the same size, with the larger pieces having fallen out. And so you have better sorting. They're sorted so that they're all the same size, and they're rounded because they've been exposed to water for longer. So upstream you might find a sedimentary rock like breccia, which is made up of bits of sediment, and they're all different sizes, and they're kind of angular grains. And downstream, or in the downstream, you might find conglomerate, which is a similar rock, but the grains are the same size and they're rounded. At the bottom of the lake, after it dries up, you're going to find things like sandstone or mudstone or shale. I think we've done enough for rocks. I think that will get you through. Good luck.